Removing the graphical interface lets AI interact directly with raw processing power. This stream of computation resolves into a solitary command line prompt. Enterprise AI assistance is moving away from the limitations of IDE-based plugins. Instead, these tools are migrating into the raw command line interface. Claude Code is built specifically for this environment. It is a terminal-based agent engineered to function as an autonomous coworker, rather than a reactive autocomplete tool. This represents a major architectural departure. Rather than pre-indexing your entire codebase, this system abandons traditional retrieval-augmented generation architectures. Instead of querying static vector databases, the AI translates prompts into standard Unix tools, executing glob, grep, and find against the active folder structure. Standard output returns straight to the AI engine, creating a closed iterative loop, mirroring how humans explore complex repositories. Scaling this specific discovery tool requires developers to reconsider the software. It must be treated as a composable, headless background process. Removing the graphical interface eliminates the need for manual, cursor-based interactions. This allows the AI to be fully automated and integrated into headless DevOps pipelines. Moving from an IDE to the terminal forces an evaluation of the architectural trade-off between static data storage and dynamic query execution. Look at the left side of this architectural comparison. Traditional AI coding pipelines rely heavily on static vector databases. The source files are chunked and converted into a rigid, static grid of text blocks before they ever reach the language model. The operational limitation here is that static blocks in an enterprise codebase become stale the moment a file changes, degrading cross-file retrieval accuracy. Now watch the right side illuminate. The LLM abandons the index and instead issues a sequence of bash commands, ingesting live data to formulate real-time queries. Anthropic categorizes this dynamic execution cycle as the pure agent approach. The LLM deploys native tools continuously to build an accurate, in-the-moment contextual understanding of the project. Deploying autonomous code execution capabilities creates immediate security implications. It demands a highly restricted permission layer to prevent the agent from acting destructively. The system achieves this by establishing a hard operational boundary between executing read actions and executing write actions. Standard read actions proceed automatically. The agent can map network folders, read file contents, and search histories without any human friction. Conversely, write commands and bash executions trigger a hard system pause. A human operator must explicitly approve the action, enforcing a strict security boundary before any local modification occurs. You can optimize this strict security bottleneck by pre-configuring auto-acceptance for standard, non-destructive commands, like running an existing test suite. You accelerate the execution time without compromising safety. Combining dynamic agentic search with granular bash permissions solves the retrieval staleness of standard RAG pipelines. Simultaneously, it prevents the autonomous agent from silently corrupting local environments. Executing dynamic CLI agents introduces a new constraint, the reliance on entirely stateless user sessions. Claude Code operates within a finite hardware limitation. It has a maximum processing capacity of 200,000 tokens per session. This progress bar illustrates that capacity limit. If you engage in extensive debugging sessions involving large terminal outputs and complex traces, you will rapidly saturate this available memory limit. To reclaim operational space, you run the /compact command. The context instantly compresses, clearing out the raw logs and resetting your available token space. This compression command generates a stateful handover note. It summarizes the crucial findings of the session, maintaining workflow continuity even across a freshly cleared context window. Managing ephemeral tokens is the immediate hurdle, but the system also requires persistent project memory that carries across independent sessions. The core memory bus for this persistent state is a project-level CLAUDE.md file. It anchors every new terminal instance to your project's rules. You drop this file in your working directory, populating it with critical architectural constraints, rigid style guides, and explicit test execution commands. You can modularize these system instructions by utilizing the @ syntax, which allows the main file to reference external, highly specialized Markdown documents. This explicit state orchestration changes the workflow. The developer's primary responsibility shifts from writing manual syntax strings to managing and optimizing the AI's context economy. Treating the agent as a raw background process unlocks massive parallelization capabilities for developers. Scaling effectively requires a planning-first prerequisite. You must instruct the agent to output a concrete search and execution plan before you authorize any code changes. As the agent works, you monitor its generated task lists. If it strays, hitting the escape key executes a hard interrupt, allowing you to stop the process and course-correct rogue execution paths. The required workflow is iterative. Command the agent to make highly granular code changes, execute static analysis, run the test suites, and commit the safe code frequently. Look at this 4-pane terminal layout. Panes 1, 2, and 3 operate as fully independent AI processes. Pane 4 holds a central text file labeled ticket.md. You can deploy concurrent instances of the agent to tackle completely disparate architectural challenges within the exact same repository. Watch the data synchronize back and forth to keep all processes informed. You manually bridge the context between these parallel agents by instructing them to use that shared Markdown file as a central database. This text-based inter-process communication forces the parallel agents to read each other's updates, preventing them from overwriting overlapping local files. Multiplexing these stateless instances allows a single developer to manage multiple execution threads simultaneously. By synchronizing through a shared file, you maintain state across a cluster of concurrent AI processes. Moving out from isolated local terminal workflows, you can scale these principles into a vast, interconnected network of automated data pipelines. By utilizing the programmatic software development kit, the agent executes headlessly within remote continuous integration and delivery pipelines. The system natively processes multimodal ingestion. If you drop a static interface mockup image into the terminal, it triggers automated scaffolding generation to match the design. The ultimate extensibility layer for enterprise architectures is the Model Context Protocol. This protocol pushes the raw terminal agent beyond local directories, integrating it directly with external application programming interfaces and broader cloud infrastructure tools. The resulting system architecture is a highly dynamic, stateless execution loop driven entirely by rigid permission boundaries and explicit memory management. Adopting this architecture shifts the developer's focus. The work moves beyond manual character entry toward the orchestration of automated, scalable deployment pipelines.